So let's see how we can use this delta epsilon applet to help us understand the relationship between delta and epsilon when we think about the definition of a limit. So within this applet, you have control over the value of x, the x coordinate of a point on this curve. You can set a value for epsilon with this slider. You can either click and drag, or if you click on each slider, you can use the arrows on a keyboard. And then you can set delta. And so what we see here is the horizontal region represents the epsilon. So this region is 0, because that's my x value, plus 0.64 and 0 minus 0.64. So that represents from negative 0.64 to positive 0.64. And when we're talking about limits, what we're trying to say in terms of the definition is what range of x values will produce the y values that we're interested in. What range of x values will guarantee that the y value is between negative 0.64 and positive 0.64. Now we can see that segments of this curve are emboldened in red, indicating that they don't fall within that range of negative 0.64 to positive 0.64. They fall without that range. What that means is this interval is far too big to guarantee results within that range. So we're going to come over here and we're going to click on Set Delta, and I'm using my arrow keys to go ahead and move this to the left so that we can shrink the interval on the x-axis that we're looking at. So continuing to shrink this, you'll see that those segments of red on the curve are shrinking as I move delta to be smaller and smaller values. So for example, right now, this vertical region we have highlighted is from 0 minus 0.39 to 0 plus 0.39. However, we can see there are still segments of the curve that are highlighted in red because they lie without this region around 0 on the y-axis. This is because there are values of x in that region that produce y values beyond what we're interested in. So keep in mind, we want y values between 0 minus 0.64 and 0 plus 0.64. So continuing to move my delta smaller and smaller, we see that shrink, and continuing to do so, and you'll notice that suddenly we have the segment of the curve highlighted in green, meaning that we have found an interval that produces y values within that range. Now, if I continue to move this, notice that I still, even though I'm making that interval smaller and smaller, I'm still producing y values between 0 minus 0.64 and 0 plus 0.64. Now what we want to do is, in general, we want to find that largest value of delta that will allow, that will produce y values between negative 0.64 and 0 plus 0.64. And you'll notice that within our horizontal region, based off the y-axis, there are segments of the curve which fall within that negative 0.64 to positive 0.64 that are not captured by my current interval along the x-axis. So what we want to do is we want to find that maximum value of delta, that maximum interval that will produce y values between 0 minus 0.64 and 0 plus 0.64. So I'm going to increase my delta and keep increasing it until I find, in other words, that sweet spot where if delta is 0.16, my x between 0 minus 0.16 and 0 plus 0.16 will produce y values between 0 minus 0.64 and 0 plus 0.64. If I increase delta to 0.17, I've left that horizontal band, that y value band that I'm interested in. And if I go less than 0.16, I now have portions of the curve where y values fall within that horizontal band, that 0 plus minus 0.64 to 0 plus 0.64, that are valid. So the maximum value of delta that will ensure function values between 0.64 and 0 minus 0.64 and 0 plus 0.64 is a delta value of 0.16.